Is Prevnar's side effect of loss of appetite worthy of being concerned about? Turn this projector off. Brandon, would you mind throwing the lights on? Thank you. Come back to the screen when we need it. What do we think? We got, what is it? It's 121 infants out of 710 had loss of appetite. Is that too far away from the normal competitive medicine, which is 13.5%? Notice no margin of error on that. Notice no margin of error on the 13.5. That's, I know a bunch of you are thinking about that right now, as you should be thinking about that. Why is there no margin of error given? Give me 2 reasons. Why do they not give us a margin of error of 13.5%? Give me 2 reasons.
They have a large sample.
But probably they've done it, it's been around for so long, it's been tested so many times, essentially the margin of error has shrunken down to expectedly 0. Thank you. That's the mathematical reason. Love that. And you can pretty much assume that across the board with a medication like this. The FDA tends to test these things over tens and hundreds of thousands of trials, which effectively shrinks the margin of error down so it's non-existent. Good. What's the cop-out reason that the media is always guilty of? They just don't give it to you. I mean, it's just not reported. So I tend to default back to the mathematical reason. It's been tried enough that the margin of error has shrunk down, which means we can treat it as simply 13.5%. It's a coin flip that flips 13.5 one side and 86.5% the other side. So if you think of it like that. So what do you think? Is Prevnar different? What do you think? What do you think? Is Prevnar different? How do we know? Say that again, Michael.
Divide 121 by 710.
Divide 121 by 710. What do you get?
17.
17. Done. Prevnar's higher. Except, is it significantly higher? I mean, that number is higher, yes? We can't claim the no margin of error on our sample, though, can we? We can't claim that. 710 is hardly tens and not hundreds of thousands of results. So we have to analyze this properly. We have to actually do this properly. And some people will roll their eyes when you tell them this kind of a thing. But that's the reality of it. You can act on a simple number like that, but you run a very, very high risk of being A, inaccurate, and B, non-believable. I mean, there's sampling error, correct? There's sampling error in any sample. And that's not bad error. That's just natural error that has to happen. Go ahead, Kate, you were going to say. That's what I'm saying. Let's go through it. Now, let's go through, if you don't mind, let's walk through the template, just because that's why I designed this for you guys, so you have the template in front of you, so you kind of see the process. And honestly, before we get to the bell curve, I want to do a whole bunch of other stuff, if that's okay, just to kind of, again, walk us through this process. All right, and this is what you'll be turning in for quizzes from now on. I mean, except for the ones like the p-value quizzes. Anytime you do a hypothesis test quiz, you'll be turning these guys in. And it's the ones when you open up, there's nothing on them except a problem statement. They're going to look a lot like your data sheet here, honestly.
So with that, do we just write like at the top of it?
Sure. Put your name and which one you're turning in. Yeah. I can usually tell by the context of what you've written in number 2 what it is. But yeah, give me something up there. Cool. Oh, sorry, JC, go ahead.
So should we not have skipped them together?
You can if you want. Strip off the ones you want to turn in if you want to turn them in. That's fine. Don't worry. I'm not like a Catholic school. I'm not repping knuckles for that. Sorry. Flashback. What variable are we testing? What variable are we testing? We're still testing little p, aren't we? The proportion of those getting sick on Prevnar, which is actually, we just answered number 2 as well as we're going. Define the variable? So we know the variable is p. We know the variable is p. What we're interested in is the percentage of those, I said getting sick, that was the wrong name. It was the proportion of those experiencing loss of appetite, right? It's the percentage of infants with loss of appetite on Prevnar.
Do we care about the confidence or how
Hold that thought. We do for sure. But one of the reasons I drew up this template, it's a very good question. One of the reasons I drew up the template was to get us thinking. Although, to keep things simple in this class, I'll tend to have you always testing at 95% confidence because you're used to that now. And that's what you see in research almost inevitably. But sometimes, as we'll see, you're willing to accept lower confidence if it means less chance of a type 2 error, which is a false negative. Now that doesn't make any sense right now. Hold that thought though. Just keep,
Because you
keep,
just want that.
right, keep 95% in your head for right now. We're basically always going to be testing at 95% in this class, but in reality, that can change. It depends on the context. And there are too many contexts to kind of explore all of them. Okay, here's the hypotheses. So I think now, Kate, it's a good time to have our bell curve. I think this is a good time to have our bell curve. I'll put it over here. Okay. A bell curve up. Excellent. Now that's technically 0 right there. That's technically the number 0, technically speaking. But what percentage is really there? What percentage is really there?
13.5.
Nice! 13.5! Because that's the status quo on the competing medication. 13.5 is the status quo on the competing medication. Good. Our job is to see where Prevnar lands on that curve. Now we know it has to land somewhere on the curve. The trick is it far enough away from 13.5 to make us believe it should be somewhere else? To make us believe it should be on some other curve. If it's far enough in the tails, then we're going to say, it might be in that curve, maybe, but it's unusual to be in that curve. It's more usual for it to be somewhere else. Now, did you catch the word I bold italicized here? I said different. I said different. Sometimes you don't test greater than or less than. Sometimes you just test different. And as we go through the course, I want to look back at these differences versus greater thans and less thans and show you why statisticians tend to like these more as far as power goes. But what this means is, essentially, this is going to be a two-tailed test. It's going to draw two lines, and it's going to put 2.5% and 2.5%. So it's going to look a lot like a confidence interval. It's going to look a lot like a confidence interval. You're going to have 2.5% here, and you're going to have, oops, I ran out of space, 2.5% here. As opposed to having all 5% in one tail or all 5% in the other tail. We've only done one of those so far. We've done the left tail test last time was the flu vaccine. The next one I've got picked out is some fun data to test the right tail. This is called a two-tail test. A two-tail test. Now this often happens in statistics when somebody doesn't want to taint a study by going in and thinking something too strongly. Like for example, if they have no idea what Prevnar is going to do, they might start by simply testing it. Is it different? We don't know if it's going to go up or down. Is it going to go either way? It gives us a choice of testing either way. Does that make sense? So if you're not trying to show that something is dropped or increased, just go in and see if it's changed. Once you've decided it's changed, if you need to, you can go back and test it again for a direction. But at least we can see if it's changed first. JC, go!
So the word different is our key.
That's the key, and I will always use that word, yes ma'am. Yes, I will always use that word, different. Because different implies, well, we'll see it in the hypotheses here in a second.
Is there a symbol for different?
There is, does not equal. This is, check this out. So let's write the hypotheses now, which is step 3, yes? Step 3, let me make sure we can see this okay. We can. Yeah. So your hypotheses, thank you. Very good question, Kate. Very good question, JC. You're trying to see if, like the Skylar's awesome question from last time, what she asked, she's like, can we do it in words too? I love that. I love that. The beauty of defining the variable, though, is the words are right there for you. You're trying to see if the percentage of infants with loss of appetite on Prevnar is different than those on the competing medication, which is 13.5%. Michael, go!
Do you want it to be significantly different though,
That's
or just different?
That's the only thing we can test, friend, is significantly. Now, significantly implies that it's outside that margin of error.
So then would you like put P in the middle and do like
We have-
one
that's-
is greater than 11?
Yes, and that's what that curve is starting for us right there, and that's what we're gonna let the machine take us the rest of the way. But we've already slumped through one of those already.
Would you want us to write this for this, at least for this?
Well, the thing about, you'll see why momentarily. I want you using technology to crunch the test statistic and the p-value. I do. But this helps you set the technology up. So that's why I like having them written out. Fair? Yeah. Good. Plus, very often, especially that study you sent me a couple weeks ago, week and a half ago, very often, if you don't have the hypotheses in front of you, or at least the variable you're testing, you get these results, you're like, what does this even mean? At least if you have this up here, you know what variable you're testing. Very good question, very good question. It's going to seem a little archaic at times and simplistic at times, but trust me, I think this is the way to really drive that point home. Good. What's the null? Exactly. It's just the same. It hasn't changed one bit.
Well, if one has it, it's the opposite.
Exactly. That brings up a good point, Kate. I want to come back to that question about 15 minutes, if it's okay, because there is a convention. I don't say concession. A convention that's been adopted with the null hypothesis to always have an equal sign, even when this is does not equals. I want to talk about that. It doesn't apply here, but I do want to talk about where it applies. But yeah, these should be opposites. If you're trying to see if it's different, you're going to go in assuming it's the same. Now, to answer Michael's awesome question in a different way, that doesn't necessarily mean exactly equal. It means significantly equal, or I should say, significantly unable to be proven any different, if that makes sense.
Or not significantly.
Not significantly different, exactly. A much more concise way of saying it. So basically, as long as it's in here,
Okay.
it's not significantly different than Prevnar. When it etches out of there, that's when it gets significantly different. And this is where your adjustment of confidence comes in. Depending on how much you want to avoid a false negative, you probably want to shrink these down even more than 95% to cut the variance down. I want to come back to that with a spreadsheet that I think will make that more clear. But let's just keep it at 95%, just to keep that thing constant as we go through the first couple weeks of this, and then towards the end we'll start messing with the confidence and seeing how things can change. Fair? Does that make sense? So far, ish, getting there. Good.
You go over and work and
Sure. We're trying to see if the percentage of infants who are using this new drug Prevnar is any different than the percentage of infants using the competing drug, which is 13.5%.
then losing their appetite.
That's the only thing we're testing. Yeah, I'm sorry. That's right. That's the variable, is whether or not they lost their appetite. Exactly. Thank you. Thank you. We're trying to see. We're testing a side effect. Each side effect needs to be tested to see if it's any different than competing meds. Because if you think about it, if you can knock off no difference in side effect, and the drug is, say, cheaper or seemingly more effective, then it's a win-win. But then there's also trade-offs. You know, certain therapies have maybe terrible side effects, but they're also very effective for treating whatever the issue is. So there's trade-offs. This is trying to minimize one of those.
Then you take another drug to help with those.
Sometimes, yeah. Maybe it can be tricky. It can be tricky, right? Good. Let's see. Let's define the types of error, because this is a big thing in drug trials. Let's go in and identify the types of error. What would a type 1 be in this case? I put it in context.
You said it was,
That's a false positive.
You said it was different, but it really wasn't.
Good. You said. Say that nice and loud, Scott.
You said it was different, but it really wasn't.
So, I'm going to put a little more context on it if it's okay. You got the heart of it, it's important. So, a type 1, a false positive, would be you got a p-value that landed out here somewhere, and you said, oh, it looks like appetite loss is different in Prevnar. That was your conclusion, but you were wrong because the appetite loss is not different in Prevnar. That's a false positive. False positive is crying wolf. Something changed, but it didn't. So that's saying that the appetite loss was different when in fact it wasn't. That would be a type 1 error. We might make that. We'll see. We'll see. Actually, we won't see if we'll make it. We might be able to make that depending on how big our p-value is. But that would be a false positive. Be a false positive. Type 1 error. Saying there is a difference in appetite loss, comma, when in fact, comma, there is no difference in appetite loss. Is that good so far? You guys buy that? That's a false positive. What would false negative be?
Saying that Prevnar is statistically the same as the competitive vaccines, but it's statistically significantly different.
I love what you just said, Michael Bird. A false negative, a type 2, would be saying Prevnar is no different, statistically the same. I love what you said there. Statistically the same, statistically no different than its competing medication, comma, but in fact, comma, it is and you missed it. That'd be a false negative. Okay, go. Which means you landed in here.
Yeah.
But that just means you got outlier data on the other curve,
I'm
wherever
just
it is.
thinking of statistically different versus practically different. Because if you landed just shy of the red line, but Prevnar, or the standard
In
drug,
3 weeks, I have a
on
great
the
quiz
other
on this.
side.
Yeah, in 3 weeks, I got a quiz on this.
Okay.
No, this is such an important
So
question.
they're still technically significantly the same if they're both on opposite sides of.
This is going to sound like a cop-out. I apologize. I can't argue practical
That's what I'm
significance.
saying. I think I'm just getting stuck on
And that's okay. You should be. That's why I slapped up pseudo-arbitrary So in this class, we're just going to decide which side of the fence it fell on. And we'll let the experts argue practical significance. Because that's all we can do in here, unless we were experts in every single, I mean, if you look through this data sheet, I don't know how many different contexts you have, and that's not even counting the ones we're going to do in class. We can't be experts in everything. We'll let the fields. So all we're testing is which side of the fence did it fall on. Fair enough? Great question. It sounds like a cop-out, but honestly, it's just efficient as far as learning it goes. In your opinion, which type is worse? Number 5. Your opinion. This is all about you. Michael, your opinion is?
I'd say type 2 because the proportion that we have from what we have so far is higher. If you're saying that it's the same as these lower ones, it's,
We have the percentage, not the proportion.
Okay, now hold tight, hold tight. Before you go any further, realize that you would have done all of this error analysis before you even collected the data in the first time. So you wouldn't know that it was 121 out of 710 in the beginning. So take that away. Which error do you think is worse, a false positive or a false negative? Type 2, type 2. Why do people saying type 2? Jamie's saying, yeah, type 2, type 2. How come again? How come type 2? I can also hear type 1. I mean, I'm not saying either one is right. I'm saying your opinion. JC.
You're underestimating what the percentage or what the effects are.
Sure. So a type 2 would say there's no difference when there is, and that's bad because...
Because you're not fully understanding the effects.
What if it's much worse?
Yeah.
And you're unwittingly putting that out into the world for parents to use on their kids, and maybe they're going to get...
When it could be bad.
Right. It could very well be a measurable side effect. We won't know until we're on the test.
And during that time of the life, appetites.
Crucial when they're infants. Yeah, good. So that's one vote and two good reasons for why type 2 is worse. Who says type 1 is worse? Type 1 could be worse too.
You
Go
never
ahead.
know. I mean.
No, but I know you never know, but which one do you think is worse? Type 1 or type
I
2?
don't think we have enough information.
Sure you do. To
We don't
form an
know- We
opinion.
don't know the prices of it, we don't.
No, don't worry about that. You're only being right or wrong about the appetite loss. Forget the prices.
That would,
Assume everything's equal and just talk about the error. What would be worse? Putting a drug out that has an appetite change rate, but unwittingly doing it, or not putting a drug out because you think there is a change, but there isn't. That's a type 1, right? Type 1 would be, no, we can't release this thing because it looks like appetite rates are different, but it actually isn't.
But does it supposedly do something else better?
It's supposed to do whatever Prevnar does, it's supposed to do. It's the meningitis drug, right, I
We're
think?
only looking at that one.
Yes, it's the meningitis drug.
But then we don't do it. I can't say negative.
Okay, that's totally fine. All I'm saying is pick one and support it. I'm not saying you can be right or wrong, because you can't be right or wrong. In drug testing, usually I hear very often the false negatives are worse because you unwittingly put something out there with a side effect that might be worse than whatever you're trying to have the drug fight against.
That happens with a lot of things though.
It does. Remember Olestra?
Oh.
Unfortunately, it was a cholesterol replacement. The idea was to I think it was a cholesterol lowering. No, excuse me, it was a fat replacement. That's what it was.
Fake fat.
It was a fake fat. Side effect?
Favorite.
Anal leakage. That's how it defines. Anal leakage.
of what? What is
If I have to answer that. So, I mean, the idea is, yes, you have a low-fat replacement, but anal leakage is a side effect. It's like, that's a type 2 error I'm really wishing that somebody had
My
caught.
favorite is the side effect of possibly death. It's like, yeah,
Possibly,
I
right.
want to go take that.
Well, the problem with side effects, basically everything has the same side effects. You might die, you might have cardiac arrest, you might develop an allergy, your toes might fall off.
You might get
But the problem is, the chance of these things happening is so minuscule. But they're still, it's just kind of like the Advil you took in 1998. It's still in your spine. Because drugs' half-lives just keep on half-lifing, and half-lifing, and half-lifing, and half-life. But there's so little left now in your body that your liver doesn't even bother filtering it anymore, because it just sits there residual. I mean, at some point it becomes so small that it's not worth talking about anymore. But they're interesting to read. They're interesting to read. Oh, JC!
Oh, finish your sentence.
That was it. That was it. It was just kind of agreeing with Kate and saying that, yes, all these things have crazy side effects, but the likelihood of them hitting you is so small. So something tells me, even if they get negative test results, they still put them on there. Kind of a CYA, a litigious thing. Yeah, for sure. Go ahead.
Does the benefits outweigh the side effects?
Always have to ask that, right?
Yeah, when I went in for my surgery and whenever like everybody goes in for your surgery, you have to sign the paperwork and on there it's like, oh, you could die. I'm like,
Yeah.
okay, or I could be pain-free. So it's really,
Is the benefit.
and what's the chance of me?
Of course. And knowing to ask that question, yes? Knowing to ask the question. And knowing knowing too, this brings up a good point, and you can't hear this enough, honestly. It has nothing to do with this particular problem or any of these hypothesis tests. These hypothesis tests are testing an average across a population, or a proportion across a population. JC is one person. You are your own person, which means the average might not apply directly to you. Always remember the wedding ring problem I told you guys about in 243. My friend Jim and his wedding ring. Never forget that. Never forget that. When I ask people, what's the chance we're going to find that ring? Ah, you're not going to find that ring. Ah, it's 1 in a million. Ah, it's 1 in 10,000. 4 weeks later, we found the ring. What? Because we changed the average. We changed the average by whatever we did. So you got to keep that in mind. Anecdotal evidence. Anecdotal evidence does have a meaning when it applies just to you.
That's why they keep doing studies and studies and
Yes.
studies. So when I had my surgery, they were doing it a lot over in Europe before they did it
Oh,
here.
interesting.
The
Okay.
FDA, because I have an artificial disc in my back.
Gotcha.
And so they, at first, the FDA only required like 3 years of data
Uh-huh.
in the US.
Gotcha.
And then they put it up to 5. And now they're doing 7 because it needs to be bigger.
Right, and meanwhile Europe has been doing it for a while, giving more data too at the same time,
Yeah,
which is
but they
also
have
good.
different regulations on it.
Of course,
So
of course,
so that's- yeah.
absolutely. And Europe always has better sunblock than we do because they push through our testing more quickly than we do. And then years later, we finally get the sunblock over here. So I'm not that's very, very good to know.
I'm just making a personal connection.
No, but you should do that because you have to know the difference between a personal anecdote and statistical averaging, which we're doing here. We're checking for all infants across this age group and this one particular drug compared to its competitor. Now we get in the nitty gritty. Now we get in the nitty gritty. We actually figure out how we're going to test this thing. We have the data. We've collected our data now. Boom. Which distribution are we going to use here? Got to use Z. Test the proportions. Got to use Z. So we're going to circle Z. Test statistic and p-value 7 and 8 all come at once. They all come at once. Now we're going to use technology to do these bad boys too. Got to use technology because we saw what happened last time when you crunch it out by hand. It's fine. You can totally do it. It just gets old after a while.